Hello again, this is Mrs. Torigno and this is page 4 of the Algebra 1B Semester 2 exam review. So this will cover questions 16 through 21. Ignore the whiteout please, my batteries died while filming this video so I had to start it over. So here with number 16, this is asking you to simplify the cube root of x to the 12th. Well, what that's really saying is you have 12 x's all in a row and you want to put them into 3 equal groups. Well, if you had 12 of something and you were putting them into 3 equal groups, what would be in each group? That's really a division question. It's really just asking you to do this. 12 divided by 3, which is 4. So I would write my final answer as x to the 4th. The shortcut rule that we use there is really just to divide the inside number by the outside number. So 12 divided by 3 gives you that x to the 4th. Okay, 17 is asking you a very similar question, except in number 17, there's no number outside the radical sign. Now there is here because I already wrote it in the last time I filmed this video. But anytime you don't have a number, it's a square root. So that means it's like an imaginary 2 out there. And I'll write this a little bigger so you can see it. Originally it said the square root of x to the 9th. And you can always, if there's not a number out there, picture a 2 out there. Okay? So I'm going to do it the exact same way that I did the last one. I'm going to do the inside number divided by the outside number. That would give me x to the power of 9 over 2. Except this time 9 and 2 don't divide evenly like this one did up here. And I don't want to put decimals in my exponent, so I'm just going to leave this exactly as is. All my question said is to rewrite using an exponent, so 9 over 2 is my exponent, and that would be my final answer. Okay, number 18 is asking me to solve, which is a different type of question. Solving means you're trying to get x by itself. So first think about what this question is saying. It's saying -3 times the cube root of all of this, 2x minus 5, is equal to 9. So I need to kind of work backwards and dig x out of there. First thing I would do is get rid of anything that's outside of the radical. I can't do anything on the inside of the radical yet. So let's get rid of what's on the outside, which would be this -3. This says -3 times the cube root. So since that's multiplication, to get rid of it, I would divide by -3. And that means I'm going to divide by -3 over here as well. That'll cancel that out, and it'll leave me with the cube root of 2x minus 5 is equal to -3, because 9 divided by -3 gives me -3. Now, to get rid of a cube root, remember the opposite of a root is a power. So, and again, I can't do anything with that 2x minus 5 until I get rid of the root. That's why I have to do that next. To get rid of a cube root, I'm going to use a power of 3, which means I'm going to raise this over here to the power of 3 as well. Lots of 3's in this problem, so don't get confused. When I raise this root to the power of 3, it's really just going to cancel out the radical. So I'll be left with that 2x minus 5. And then over here, -3 to the power of 3 is -27. If you weren't sure about that, you could use a calculator. Okay, from here, this is just a basic 2-step equation. I'm going to take it over here so I have some room. But 2x minus 5 equals -27. I would add 5 to both sides first. That's going to leave me with 2x. And -27 plus 5 is -22. Divide both sides by that 2. And x would end up equaling -11. And that's your final answer. That's what it's asking us to find. Okay? And that's it for that one. Okay, 19 and 20 are, again, very similar to one another. And the directions are different here again. It says to simplify. These are your favorites. Simplifying involves making a factor tree. Okay, so I'm going to need a factor tree for 30,000 here. Let's see. Trying to pick the best space to do this. Okay. So here's my 30,000. And I'm going to break that up into 30 and 1,000. Notice for right now I'm ignoring the p to the 14th. We'll come back to that in just a minute. Okay, let's see. 30 can break down to 6 and 5. And 6 can break down to 2 and 3. 1,000 I could make 10 and 100. 10 I could make 2 and 5. 100 I could make, let's go 20 and 5. 20 I could make 5 and 4. And then 4 could be 2 and 2. Hopefully you can read that. So kind of a lengthy factor tree here. Okay, when you're simplifying, you're looking for pairs. And I'm doing pairs because this is a square root. Okay, so that means groups of 2. If you were doing the square root of 25, that means you're looking for 2 numbers that multiply by themselves to make 25. That would be 5. So here, I want to find pairs of numbers that match. So for example, I have a pair of 2s here. So for every pair, I'm going to put one number on the outside. I'm going to put a 2 there to show that I used that pair of 2s. Then here I have a pair of 5s. So I'm going to put a 5 on the outside. And again, you're only looking at the numbers at the bottom of the factor tree. So like the 4, the 20, the 100, those ones are broken down further, so I don't want to use those numbers. Let's see. I have another 2 and 2. So because I have another pair of 2s, I'm going to put a 2 on the outside. And then I have a 5 and a 5 again. So I can put another 5 on the outside. I think that's everything, and I've got this poor lonely 3 left over. Okay, so over here, let's make sure you can see that. Over here, I'm going to put my square root symbol back, and the 3 stays underneath it because it didn't pair up with anything. So all of these represent pairs of numbers, and then this represents what was left over. Okay, let's go back to that p for a second because it gave me p to the 14th in here as well. You probably don't have to write this out, but I want to show you what it's really asking you to do. It's asking you to do something similar to this. So p to the 14th means I have 14 p's. 4, 5, 6, 7, 9, 10. And it wants you to pair those up just like you paired up your numbers. So I would say, okay, here's 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs, 6 pairs, 7 pairs. Okay, again, you probably didn't need to write out 14 p's to know that you would have 7 pairs. It's really just 14 divided by 2. But I wanted you to see where that was coming from. So really, since those all paired up, it's like I'm putting 7 p's on the outside with my 2s and my 5s here. Okay, now I'm not going to write out 7 p's. I'm just going to write it as p to the power of 7 because that represents 7 p's. And the only other thing I would do here is I'm going to go ahead and put these together. So, excuse me. Pardon me. 2 times 5 is 10. 10 times 2 is 20. 20 times 5 is 100. So when I put those back together, and remember you're putting them together with multiplication, it would be 100 p to the 7th, and then you would have a square root of 3. And that, after all of that, is your final answer. So that's your simplified answer, 100 p to the 7th, and then square root of 3. So simplify really just means to pull out whatever you possibly can. Okay, I'm going to try to wall this off a little bit so that we can keep the next problem straight. Next problem is asking us the same thing. It says simplify, hopefully you can see it in all this mess, but it says simplify the square root of 600 m to the 11th. Well, I'm going to need a factor tree for 600, and I'm going to go over here in the corner. Let's say 600 is 6 and 100. By the way, it doesn't matter how you start your factor tree. If you had gone 60 and 10 or 2 and 300, it would work the same because when you get down to the end, you would still end up with all the same factors. So if you chose to do a different factor tree than me, that would not change your answer at all. Okay, 6 becomes a 2 and a 3. 100, I'm going to do, I guess, 10 and 10. And then these both become 2 and 5. This is, I'm going to kind of branch this off to the side. 2 and 5. Let's see what we have pairs of. So it looks like I have a pair of 2s here. So I'll put 1, 2 on the outside. And it looks like I have a pair of 5s. And then I have a 3 and a 2 left over. So on the inside of my square root, I'll have a 3 and a 2. Again, I'm sorry about the mess on that. I hope you can see that okay. And then here I have 11 m's. Let's see if we can do this without writing them out. If I have 11 m's, think about how many pairs you could make. Out of 11 m's, you could make 5 pairs. So I would have m to the 5th. And you would have 1 left over this time. So here on the inside with the 3 and the 2, I'm also going to have an m. So let me clean this up a bit. 2 times 5 is 10, so this will become 10m to the 5th. And then 3 times 2 is 6 with that m that's left over. So my final answer will be 10m to the 5th and then square root of 6m. And that's my simplified answer for number 20. Okay, number 21 jumps into chapter 9, which was exponential growth. And it gives you this equation, y equals 2 times 3 to the x, and it just wants to know if this is growth or decay and why. Well, the general equation for exponential growth is this, ab to the power of x. I guess I should say growth or decay, where a is your starting value, b is your growth factor, and x is your time. If you're trying to decide between growth and decay, the b is really your biggest indicator. So in this equation that it gives us, it says 2 times 3 to the x. The 3 is your b. And the way you tell the difference is if your b is bigger than 1, it's going to be growth because that's more than 100%. If your b is less than 1, it'll be decay. So since 3 is bigger than 1, I would call this growth. And when it asks why, I would just say because 3 is bigger than 1. There's some nice shorthand for you. Okay, but growth because the 3, which is your b value, is bigger than 1. Okay, that's it for this video. I'll pick up on the next one with page 5.